So good morning everyone. Welcome to the channel Algo Optimizer. So today we are tackling the today's LeetCode daily challenge, which is 3186 maximum total damage with spell casting. So I will give you a quick recap of the problem. So we are given an array called power, okay, and in the power, each number in this power represents the damage value of a spell. Our main goal is to choose a set of these spells to cast and achieve the maximum possible total damage. But see, it is a known fact that if a magician decides to cast a spell with a damage of power I, they cannot cast any spell with a damage of power of I minus 2, minus 1, plus 1, and plus 2 accordingly. Okay. So see, now here is the important part, the rule that makes this problem a bit of challenging. The magician has a strange jurisdiction. If they decide to cast a spell with damage X, then he cannot spell the like spells with plus one, minus one, plus two, and minus two power. For suppose I have a certain elements in this power set or power array, okay, and I am choosing this ith power of the spell. So now since I've taken the power of I, or I should say since I used the ith spell's power, which is power of I, so I cannot take this power of I plus 1, power of I plus 2, and power of I minus 1, and power of I minus 2. Okay. So थोड़ी सी कंफ्यूजन हो रही होगी बट सिंपली इतना समझ लीजिए कि if we are taking the power of I, so if the element which is equals to power of I plus 1, I plus 2, and I minus 1, and power of I minus 2. So we cannot go with those powers. Okay. So एक एग्जांपल से लेते हैं जो टेस्ट केस है. Powers is given as 1, 1, 3, and 4. So suppose as a magician, I am considering this power. Okay, so I am taking this power. So what powers we cannot take in further? So it would be 4, 5, and 2, 1. Okay, so this power we cannot take. We can take as much as 3. Like suppose if there is three threes. Okay, so 1, 1, 3, 3, 3, and 4. So we can take all the three threes at once, but we cannot take 1, 2, and 4. Okay, so in this case, our answer would be 3 plus 3 plus 3, which is equals to 9. Okay, but and see, let me just clear this. And if I talk about this element, so I can take 1. If I'm taking 1, then I cannot simply take 2, 3, and 0 minus 1. Okay, so I can take as much as 1 I want. So 1, 1, so 1 plus 1 that I can take. Now I will go further. So 3. So see 3 is here. So I cannot take 3. And 4. So I can take 4 as well. So my total powers which I can use is 4 plus 2, 1 plus 1, which would be 6. Okay. So like this, the problem is saying. So this is simply if we can observe. So this is simply not take and take, which is a subsequence problem. Like we have to take a certain subsequence of the array, and which is typical type of like a dynamic programming question. It is very conventional problem. Like सिंपली डायनामिक प्रोग्रामिंग में यूज हो जाएगा इसमें क्योंकि इसकी बेसिक इंट्यूशन हमको यहाँ से बनानी है कि एक एरे दिया हुआ है हमको. सपोज ये इस केस में ये एरे है पावर हमारा, ठीक है. तो पावर एरे में से हमको बहुत सारे स्पेल्स के पावर दिए हुए. सो वी हैव टू टेक द combination of these spells. So we can take ith spell, I plus X spell, whatever spell I want, I can take. Okay, so suppose we are taking this spell, I am taking this spell, and then I am skipping those certain level of X spell, and after that I am again taking this spell. So my total answer would be whatever combination I am taking of the power. So it is nothing but subsequence of the power array. Okay, so it is simply take not take question. So see, this is my power array. Wait, and so many elements are given. So suppose one, one, two, three, six, seven, seven, 8. So for this element, I have two choices. Either I can take this element or either I cannot. Okay. For these also I can take, I cannot. For these I can take, I cannot. So it is simply a take and not take. Okay, not take or not take, whatever you can say. And we have to give the maximum of these. Okay, but the slight challenge is here. So here is the twisted condition. See, this one. It is given that we cannot choose the spells with power of I minus 2, power of I minus 1, plus 1 and plus 2 if we choose the power of I as our spell. So in this array, suppose if I choose 3, so next I cannot choose 4, 5 or 2 and 1. So all these and 4 or 5 is not there, so I can directly choose 6. But if we the basic point is to say like जो main point जो मैं कहना चाहता हूँ वो है कि अगर if I am choosing 3 then I cannot take 1 2 or and 4 and 5. Okay, so this is a slight modification from the conventional not take or not take dynamic programming problem. The dynamic programming I am saying because if you do with the recursion, direct recursion, so the total complexity of this like take not take, so it would be goes to 2 raised to n power, and n here is equals to 10 raised to power 5. In this question, our n, which is equals to power size, is given as 10 to the power 5. So it would go beyond the 10 to the power 8 second. So this complexity 2 raised to n will go beyond 10 raised to power 8. So it will give TLE. Okay. So it would give TLE. So we cannot do directly recursion. So we will go with the dynamic programming. Okay, so in this, what we can do? So see, now understand. We have understood the problem. Okay, so as far as we know the problem, we know that हमको power array दिया हुआ है एक, उसमें से हमको specific spells choose करने हैं. लेकिन condition क्या है? If we are choosing the power I, like if we are choosing the ith spell, then we cannot choose plus one, plus two, minus one, and minus two. So first of all, we can we have to use data structure such as map and all to store the element. Like it is given in the question that there can be multiple entries. Like in the test case itself, it is given as 1134. So we will use a map. Okay, order not ordered. Like we will do ordered. I'll explain it later on why we are choosing ordered map. So see, we are our ordered map would be like this. So one, it is coming two times. Three, it is coming one times. So what total values it is adding? So तीन एक बार आ रहा है तो उसकी टोटल पावर कितने मिस कर सकते हैं? तीन. चार एक बार आ रहा है तो उसकी पावर चार. फॉर सपोज एग्जांपल वन वन टू टू and four and four. Okay. So in this case, our map would be like map for this array. Our map would be like one would be two times. क्योंकि सपोज हमने वन एज अ स्पेल लिया है, हमने वन ये जो पावर वाला है वो ले लिया है, तो वन वाले हम कितने भी ले सकते हैं. वी कैन टेक एज मच एज वी वांट, बट वी कैन नॉट टेक टू थ्री एंड जीरो एंड माइनस वन इफ वी आर टेकिंग वन. Okay, so but for one we can take as much as we want. So one would be two, and this two would be two plus two, which is four, and four. This four would be 4 plus 4 plus 4, which will be 12. So it simply says that the element power of element 4 is present in this power array, and it is basically present three times, and which would add the value of 12 because it is coming from 4 plus 4 plus 4, if you are not understanding. Okay, क्योंकि 4 तीन बार आ रहा है तो हम टोटल जब एक साथ स्पेल लेंगे ये फोर्थ वाला पावर ऑफ ये 4 जो लेंगे तो वो तीन बार ऐड होगा। एक साथ हम इस कितने भी ले सकते हैं इसको, तो ये टोटल वैल्यू ये ऐड हो जाएगी। And now we would take the set or array of these elements so that we can do directly, we can jump on the unique spells. So suppose 1 1 2 2 3 4 4. So this power array would be directly decrement to this one, 1 2 3 and 4. So we were only taking the unique values. Okay, if some value is repeating, then we would not consider that. So as far as we have discussed, we are taking map in which we are taking value with the total value. Okay, value means I should write spell power. Okay, I will write spell. Okay, so we are taking the map which would be spell and total value, and after that we would make two arrays. Suppose array 1, which would be of all the map dot first entries. What does it mean? It means simply means the unique values, and array 2, which would be of map dot second entries. So which would be nothing but see in this case, if I take this case, if I take this case, so our array 1 would be 1, 2, and 4, and array 2 would be 2, 4, and 12. Okay, so so we have discussed the problem. Okay, so इसमें हम dynamic programming directly use कर सकते हैं, and the total time complexity would be n, and n into k. Okay, I'll explain it while discussing the code. And if I write this code, if I tell this code, okay, see, this is the recurrent brute force code, in which what we are doing, we are simply just initializing this map, okay, which we storing this. This is nothing but what? All the elements of the power. So we are basically considering the power. Suppose 1 1 3 4. So 1, map of 1 would be equals to plus equals to 1. Okay, again if 1 comes, then again 1. Or suppose 3 and 3 comes, then map of 3 would plus equals to 3. So as many time as the element repeats, so we will add it, and we will create our store, which is our map. Okay. After that, you have remembered I have spoken about this array 1 and array 2. जो array 1 and array 2 हम लिए थे, जो कि होगा यूनिक एलिमेंट्स की वैल्यू सारी, जो कि होगी मैप की फर्स्ट वैल्यू सारी, एंड array 2 will be our total values of map. So it would be nothing but map's second values. Okay, and this is simply our recursion function, in which we are doing nothing but normal recursion. So we are doing this note take, in which what we will do, suppose this is our power array, this is our power. Let me just explain in this. Okay, so see, this is our values, and see, if we are starting from here, so we are taking this element, then what we will do, we will search for the next element, which is whose value we are taken this element. Okay, and we will go for the next element whose value is less than equals to power of I plus 2, and we will start from there only. Suppose this value is 1, so we will look for 1 plus 2, which is 3. Okay, so we will look for a 4 because one we have already taken, two we cannot take, three we cannot take. So we will look for a 4 in this remaining array. Okay. So since suppose for example we have taken 3 from here. So we will look for a 3 plus 2 which is 5. So 3 we have already taken, 4 we cannot take, 5 we cannot take. So we will go for a 6. Okay, so 3 plus 2 we will go for that only. So but we since we know that we have used this map dot first, which is already on the sorted manner. So, and the benefit of the sorting is we can see now. So, since ये ऑलरेडी sorted है तो हम यहाँ पे डायरेक्ट अपर बाउंड फंक्शन लगा सकते हैं ठीक है जैसे कि यहाँ पे 6 हमको वी आर फाइंडिंग 6 ओके सो वी कैन डायरेक्टली कॉल द अपर बाउंड फंक्शन इन दीज एरिया so that you can implement on your side like you just try करना एक बार implement करना इतना hard नहीं होगा now we are doing linear search see now here we are directly doing linear search simply we are first not taking अगर हम इसको एलिमेंट को नहीं लेते समझो कि पावर में से हमारे पास दो ऑप्शन है only two options we have either we can take the element or we can leave the element okay if we are leaving this element then we will simply go further at the I plus 1th index suppose if this is ith index then we will simply go at the I plus 1th index okay. So we have two options. First, we will call recursion for simply I plus 1 and all. And if we are taking the element, then we will go for total of our I, values of I, whatever values, power of I, whatever value, power of I. It will leave. Okay, so you understood this is our first choice, recursion of I plus 1. If we are leaving this and if we are taking this, then our second choice would be total of what is this, power of I or the index whatever we are talking about plus recursion of j element and what is j is the one we which we have find in the array with the help of upper bound or linear search okay j is like suppose the current element is 3 then j would be what the upper bound of 6 3 plus 2 plus 1 so 6 so j would be nothing but our upper bound so next element suppose this 3 3 4 and 7 8 so suppose we are at this index I so our next element what it would be nothing but 7 since 5 is not present 6 is not present directly 7 is present and 4 we cannot take 3 is there so 4 5 we cannot take so our next element would be 7 okay so here the j is nothing but what I plus 1 plus 1 plus 1 so whatever index is of this is jth index so it would directly go here okay so simply we are doing what recursion of I plus 1 and the remaining parameters and finding j wait sorry for this find j index and total of I plus recursion of j okay so this is what take or this is not take and this is take this is we are leaving and this is we are taking considering okay and the final answer what would be our final answer so we have to return the maximum of this take and no take like leaving and taking so we would return the maximum of these two it is simply our what we would say normal dynamic programming of taking and not taking but with slight modification okay see, we are taking this, we are skipping directly, we are going to the next index and the remaining parameters. So, and for j, we are finding j with the linear search here. But for efficient use, you can use upper bound. Upper bound of what? Current element, which would be our spell of I and plus 2 upper bound of this okay so directly you can use upper bound of this but here in this case we are doing linear search but because it won't be a problem for the one okay So problem नहीं होगा तो we'll do take. Since we have already taken not take, so we'll go for take. If you are taking this, so we are adding total of I and recursion of again we are calling from the jth index and directly we will return this. But see, what would be the problem in this? This is we are not using the dynamic programming. So if I like just if I submit this question, then it will throw the time limit error. Okay. So see, I will show you. Okay. Just give me a second. So, okay, my screen is visible now. So see, if I'll do run this, it would get run on the test case because it is not that much. But if I try to submit this without DP code, then वो वही return कर देंगे. अगर नहीं है तो we would go further and we will check for the rest of the take and non-take. Okay, so we are doing exactly this the same thing in this recursion part. And now at this time, we'll calculate maximum of take and non-take for dp of I and we will return the dp of I. So normal, if you are understanding the recursion part, there would be no, oh, wait, there would be no problem for understanding this part also. Okay. So it is best. So now I am going to run and show you this, what this part, optimized code of dp. It should run. It should get submitted this time. If the code is correct, then it would get submitted. See, this is getting submitted. Okay. So understand the basic problem, like understand the basic main thing in today's problem is this. Like we have to simply identify the pattern, or I should say the problem means, with this is the problem of subsequent find. We have to find subsequence of the array, which is the conventional problem or typical problem of dynamic programming, but the slide modification is given here, so this problem is getting like more interested. थोड़ा सा मॉडिफिकेशन ही है कि हमको ये जो पावर्स के आसपास की जो वैल्यूज है +1 -1 +2 -2 वो हम नहीं ले सकते, ठीक है. अदरवाइज एवरीथिंग वुड बी सेम. सो if you didn't understand any part of the video, then you can just simply go back and revise the video and you can just rewatch the video. Happy coding. Okay. If you like the video, then just like, share, and subscribe. Okay. Bye bye. See you next time.